Hello everyone. Today I am excited to share insights on how urban traffic data visualization can transform our approach to city planning and congestion management. By harnessing the power of data, we can uncover patterns and trends that are crucial for developing smarter, more efficient transportation systems. Let's explore how innovative data visualization tools not only help us navigate through the data but also pave the way for smoother journeys on our city streets. This slide outlines the structure of our presentation today. We will begin with an introduction to the context and relevance of traffic data visualization in urban settings. Next, we will define the specific problem we are addressing, highlighting why it's critical to tackle this issue. Our discussion will proceed to the research questions that guided our study, followed by the methodology or approach we employed to answer these questions. We will then dive into the results we obtained, discuss potential future work to expand our findings, and conclude with a summary of what we have learned and the implications of our work. This roadmap will help us explore how data visualization can effectively address urban traffic challenges. Today, we delve into the urban traffic challenges faced by New York City, a vibrant global hub for its significant cultural and commercial footprint. Yet, this prominence comes with its challenges, notably the increasing traffic congestion fueled by a growing population and high dependency on car transportation. Significantly, the rise of ride sharing services such as Uber has reshaped traffic patterns. These services, while convenient, tend to increase traffic volumes, especially during peak hours, thereby complicating daily commutes for millions. Our project focuses on analyzing traffic data from Uber collected from July 2014. Our aim is to visualize and better understand the dynamics of traffic flow and congestion in the city. Through this analysis, we employ advanced data visualization tools and techniques to dissect these complex patterns. The objective is clear: to provide actionable insights and strategies that urban planners can utilize to enhance traffic management and regulate cab movements, ultimately aiming for a more sustainable urban mobility system. Let's explore how data can guide us in making informed decisions to alleviate urban traffic congestion. Moving towards slide 4. In addressing the traffic issues exacerbated by ride sharing services, our project identifies several key challenges directly linked to the rapid adoption of platforms like Uber, especially in densely populated urban areas such as New York City. Firstly, our analysis focuses on identifying peak traffic hours when Uber rides have the most significant impact on congestion. Understanding these times allows us to better forecast demand and adjust traffic management strategies accordingly. Secondly, we pinpoint traffic hotspots, areas with the most significant traffic buildup. By identifying these areas, we can target specific locations for interventions and improvements to alleviate congestion. Lastly, our project delves deep into the spatial and temporal patterns of ride sharing traffic. We analyze how these services influence urban traffic flow and explore how these trends vary between weekdays and weekends. This comprehensive approach enables us to grasp the full extent of ride sharing's impact on city traffic and to propose tailored solutions that accommodate daily and seasonal variations in traffic flow. By addressing these challenges, our aim is to foster a more sustainable and efficient urban transport system, reducing congestion and improving the quality of urban life. Slide 5 is explains us why this problem is so important to us. Understanding the implications of ride sharing on urban traffic is not merely an academic exercise. It has tangible benefits that extend to every facet of city living. Let's explore why tackling this problem is so crucial. First, optimizing urban mobility. By identifying and analyzing the traffic patterns associated with ride sharing services like Uber, we equip urban planners and policymakers with vital data driven insights. These insights are crucial for designing strategies that not only alleviate traffic congestion but also enhance the functionality of public transportation systems, ultimately improving the daily commute for millions of city dwellers. Next, the impact on infrastructure. This knowledge helps pinpoint areas that might benefit from infrastructural adjustments, such as designated drop off zones, which can significantly reduce traffic disruptions during peak hours and improve overall traffic flow. Lastly, fostering sustainable growth. These insights are essential for policymakers to make informed decisions that accommodate changing travel patterns, thus supporting sustainable development and effective transportation networks that are resilient in the face of growing urban populations. In summary, by addressing these critical issues, we aim to contribute to the creation of more livable, efficient, and sustainable urban environments. In our quest to understand the impact of ride sharing services on urban traffic flow, specifically looking at Uber's influence in New York City during July 2014, we have identified several critical questions that guide our research. What time of day had the most Uber rides? This question helps us identify peak operational times for Uber, shedding light on when congestion might be highest. Which Uber base had the highest ride count during this period? By pinpointing the busiest hubs, we can suggest targeted traffic management interventions. What geographic areas showed the most frequent Uber rides? This allows us to map the hotspots of ride sharing activity and understand regional demand patterns. Were more Uber rides closer to the Metropolitan Museum or the Empire State Building? This question explores the impact of major landmarks and tourist attractions on ride sharing traffic. Did weekends or weekdays have more Uber rides in July 2014? This comparison provides insights into how ride sharing varies between workdays and weekends, helping to tailor traffic management strategies for different days of the week. Each of these questions aims to dissect the complex fabric of urban transportation affected by ride sharing, providing us with detailed insights that can be leveraged to improve traffic flow and urban mobility. In this study, our approach to analyzing the impact of Uber on urban traffic involved several key steps, starting from data collection to the application of advanced statistical analysis. Let's break down these steps. Data collection. We utilized a robust data set from Kaggle, which includes detailed Uber ride data for New York City in July 2014. This data set serves as the foundation of our analysis. Pre-processing. The data underwent a rigorous cleaning process to ensure accuracy and reliability. We also enriched the data set with geographical coordinates using powerful Python libraries such as Pandas, NumPy, and GeoPy. This step was crucial for preparing the data for detailed spatial analysis. Visualization. To make our data interpretable, we employed advanced visualization tools including Matplotlib, Seaborn, and Folium. These tools allowed us to create a variety of visual outputs such as bar plots, line graphs, heat maps, and geographical maps. These visualizations helps in illustrating the spatial and temporal distribution of Uber rides, highlighting traffic hotspots and trends over time. Last, statistical analysis. Finally, we applied t-tests and inferential statistics to compare usage patterns and draw meaningful conclusions about the data. This statistical approach helps us quantify the impact of Uber rides on traffic congestion and evaluate the effectiveness of potential traffic management strategies. Through this comprehensive approach, we aim to provide a holistic view of the impact of ride sharing services on urban traffic dynamics. In this segment of our presentation, we delve into the results derived from our data analysis, specifically looking at Uber usage patterns in New York City during July 2014. Our first hypothesis tested the correlation between Uber peak hours and standard commuting times. The analysis confirmed that the peak hours for Uber coincide with typical commuting hours, particularly between 5 p.m. to 8 p.m. on weekdays. This pattern suggests a heavy reliance on Uber services during evening rush hours, likely due to commuters preferring Uber for their journey home. The visualizations you see here help illustrate the findings. Heat map on the left, line graph in the middle, and bar chart on the right. Our second hypothesis examined the variation in Uber pickup density between commercial and residential zones within the New York City, particularly focusing on high traffic areas such as Midtown and the financial district. As our data indicates, Uber pickup density is significantly higher in commercial areas compared to residential zones. This is illustrated by the visual data presented here. These visualizations underscore a critical insight. Commercial zones not only attract more Uber rides, but also serve as pivotal hubs for ride sharing activities, underscoring the need for targeted traffic and public transportation strategies in these areas. This pattern reflects the broader implications of urban economic activities on transportation dynamics, suggesting that ride sharing services are most heavily utilized where commercial activities are concentrated. Moving on to our third and final hypothesis, we explored the differences in Uber usage patterns between weekdays and weekends. Our findings highlight notable variability, suggesting distinct usage behaviors depending on the day of the week. KDE plot, the kernel density estimate plot, illustrates the distribution of p-values across different times, showing a significant peak during typical weekday commuting hours, indicating high Uber usage. The bar graph is in the middle. Time series plot is in the right. The time series plot is the plot of time against p-values for weekdays versus weekends, the orange line, further supports the hypothesis. There's a clear spike in Uber usage on weekdays during rush hours compared to a flatter line on weekends, indicating a more even spread of rides throughout the day. These visualizations confirm that Uber rides peak during weekday commuting times, aligning with the patterns of work-related travel. In contrast, weekend usage is more evenly distributed, likely reflecting leisure or non-commute travel. These insights are crucial for urban planners and policymakers as they indicate the need for different traffic management strategies during weekdays and weekends to accommodate varying traffic volumes and usage patterns. Moving on towards slide 11. As we look forward the future of our research on urban traffic dynamics influenced by ride-sharing services, we have identified several avenues for further investigation. Longitudinal analysis will provide a deeper understanding of the evolution of ride-sharing benefits and challenges over time. Comparative analysis will help us compare and contrast usage patterns across platforms and better understand market dynamics and user preferences. Deeper data integration will allow us to uncover complex relationships and factors influencing ride demand, such as population shifts or changes in public transit availability. Predictive models will be invaluable for urban planning and traffic management, enabling more proactive strategies. Environmental impact study. By understanding their impact on emissions and traffic congestions, we can contribute to the development of better regulatory strategies and more sustainable urban environments. These future projects will not only extend our current research, but also enhance our ability to make informed recommendations for improving urban mobility and reducing congestion. In conclusion, her study has provided important insights into the dynamics of Uber usage in New York City and its implication for urban traffic management. Peak commute hours, commercial district hotspots, weekday versus weekend patterns, traffic management implications, and future research opportunities were some of the key points covered in our project. As we move forward, our goal is to leverage these insights to assist urban planners and policymakers in creating more efficient and less congested urban environments. Last but not the least, thank you so much for your attention and engagement during this presentation. I appreciate your time and interest in exploring the impacts of ride-sharing services on urban traffic with me. I hope the insights shared today will contribute to ongoing discussions and initiatives aimed at improving urban mobility and reducing congestion. Thank you once again.